Hello students, today we will solve the problems based on combination of resistances. So here is the question. Three resistors are connected as shown in the diagram. So here we have the three resistors. First one is 5 ohm, this one is 10 ohm and this one is 15 ohm. Through the resistor 5 ohm, a current of 1 ampere is flowing. Through 5 ohm resistor, the current is 1 ampere is flowing. We have to calculate what is the total resistance, and we have to calculate what is the potential difference across AB and across AC. And third one, what is the current through other two resistors. So this is the question. Now look at the circuit diagram carefully. Here they have mentioned total 3 points A, B, C. Okay. Now the direction of the current they have mentioned, that current is flowing in this one direction, that is the current is 1 ampere. Now look at here, the first question, what is the total resistance? Fine. Total resistance. Total resistance. Now here in the circuit diagram, these two resistors are in parallel. Okay. Here 10 ohm and 15 ohm resistance are in parallel. This implies that equivalent resistance is equal to, we have the formula R1 into R2 divided by R1 plus R2. This is the equivalent formula when the resistors are connected in parallel and we have the resistors, only two resistors. This is equal to R1 it is 10, R2 it is 15 divided by R1 10, R2 15. This is equal to 10 into 15, it is 150. 10 plus 15, it is 25. Now divide this one. 25 ones are 25. 25 6 are 150. Therefore, the equivalent resistance is equal to 6 ohm. Okay, the equivalent resistance is equal to 6 ohm for these two resistors. Now the next step is we have to redraw the circuit. Redraw the circuit. Redraw the circuit. Here this one point A as it is. The resistance 5 ohm as it is. The point B as it is. In place of these two, we have the equivalent resistance which is having the resistance 6 ohm. So here the 6 ohm resistance, and this one point C as it is. Okay, so this is the circuit diagram after redrawing. Now in between the point A to C, we have two resistors, and these two resistors are in series combination. This implies that, so you can write here 5 ohm and 6 ohm are in series. are in series. This implies that R equivalent is equal to R1 plus R2. This is equal to R1, it is 5, R2, it is 6. This is equal to 11 ohm. So we got the equivalent resistance is 11 ohm. Now let's move to the next question. What is the potential difference across AB and AC? Potential difference across AB. Okay, now see here. Potential difference across AB. Now apply the Ohm's law. You will get the potential difference. Fine. By Ohm's law. By Ohm's law, V is equal to I into R. This is equal to the current flowing through the 5 ohm resistor. How much? 1 ampere. What is the resistance? 5 ohm. This is equal to 5 volt. So the potential difference across AB is 5 volt. This is 5 volt potential difference. Now across AC, potential difference across AC. Across AC. So by Ohm's law, V is equal to I into R. This is equal to, what is the current is going to flow? See here, they have mentioned 1 ampere. It means the current is going to flow from A to C is only 1 ampere. Current is 1 ampere. Okay, now current is 1 ampere. In between A and C, what is the resistance? Right, already we have simplified the equivalent resistance. In place of these three resistance, we can fix a single resistance which is having the resistance 11 ohm. So 11. This is equal to 11 volt. So the potential difference across AC is 11 volt. So here you can write across AC the potential difference is equal to 11 volt. Okay, right. Now next question. Third one. What is the current through other two resistor? Here for the 5 ohm resistor we have the current 1 ampere. We have to calculate what is the current flowing through 10 ohm resistor and 15 ohm resistance. So here current through 10 ohm resistance. Current through 10 ohm resistance. By Ohm's law. Okay, by Ohm's law. We have V is equal to I into R. Therefore, I is equal to V divided by R. Now, this is equal to V. Now, here the potential difference across 5 ohm resistance is 5 volt. Across AC, it is 11. Now, what about the potential difference between B and C? Obviously, 11 minus 5, it is equal to 6 volt. Got the point? Once again, I shall repeat. The potential difference across 5 ohm resistance is, we got 5 volt. we got 5 volt. Across AC, the potential difference across AC, we got 11. Here we are calculating the current through 10 ohm resistance. Calculating the current through 10 ohm resistance. So the potential difference, it should be in between B and C. So here 11 minus 5, so you will get 6 volt. So 6 divided by, what is the resistance? That is 10. This is equal to 0.6 ampere. So the current flowing through the 10 ohm resistance is 0.6 ampere. Similarly, current through 15 ohm resistance. 15 ohm resistance by Ohm's law. By Ohm's law, I can write I is equal to V divided by R. This is equal to V, it is 6 volt, R, it is 15. This is equal to, divide this one, it is 60. 15 ones are 15, 15 fours are 60. So we have I is equal to 0.4 ampere. 0.4 ampere. So the current flowing through 15 ohm resistance is 0.4 ampere. You can cross check the answer. Look at here. The main current is 1 ampere. When the current reaches at the point B, it has 2 paths. Okay, let's suppose that it is I1 and it is I2. So current is 1 ampere. So we got how much? First one is 0.6 ampere. Second one is 0.4 ampere. Now add these two. How much it is? That is I is equal to I1 plus I2. You add these two. It is 1 ampere only. The current flowing is 1 ampere only. Hence, whatever the values we got, it is correct. So hence, we have solved the problem. Okay. The next problem is, the given circuit is here. It is 10 ohm resistance. It is 40 ohm, 30, 20 and 60. Calculate the total resistance in the circuit and total current flowing in the circuit. Now look at the circuit diagram carefully. Total here we have 5 resistances. Now you just look at here. These two resistances, you just look at here. These two resistances are in parallel combination. Okay, and these three also are in parallel combination. So first you solve for these two. So first one question, total resistance. Total resistance. Here 10 ohm and 40 ohm. 10 ohm and 40 ohm are in parallel. Okay, are in parallel. So this implies that R equivalent is equal to R1 into R2 divided by R1 plus R2. Okay, so this is equal to R1 is 10, R2 is 40 divided by R1 is 10, R2 is 40. So this is equal to 10 into 40, it is 400 divided by 10 plus 40 is 50. Okay, right. Now 0, 0 get cancels together. 5 ones are 5, 8s are 40. So therefore R equivalent is equal to 8 ohm. R equivalent is equal to 8 ohm for these two resistors. Now redraw the circuit. Now here we have a single resistance which is 8 ohm, and these all are in parallel combination. These are all are in parallel combination. So here we need to be keep as it is. Okay. Now you just see here. This is 30. This is 20. And this is 60. Okay. So first what we have done, we have simplified the equivalent resistance for these two resistances, and we got 8 ohm, and we need to be redraw the circuit diagram. Now you see here, these three resistors are in parallel combination. Here 30 ohm, 20 ohm and 60 ohm are in parallel. Therefore R equivalent 1 by R equivalent, because here we have three resistors, is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is equal to 1 divided by R1 is, it is 30, R2 is, it is 20, R3 is, it is 60. This is equal to, take the LCM. LCM is here 60. Now 32 is 60. So here it is 2, and here it is 3. Here you will get 1. This is equal to 6 divided by 60, and here we have LHS side 1 divided by R equivalent. Take the reciprocal. R equivalent is equal to 60 divided by 6. 6 ones are 6. 6 6 are 6 tens are 10 ohm. Therefore R equivalent is equal to 10 ohm. Got the point? Now redraw the circuit. Here this one 8 ohm resistance I will keep as it is. Fine. Instead of all these three resistors, we got the single resistance which is having the resistance, that is 10 ohm. So it is 10 ohm, and these two are connected to the battery with the plug key, and potential difference is, it is 12 volt. Okay. Now you see these two resistors are in series combination. Here 8 ohm and 10 ohm are in series. Therefore R equivalent is equal to, what is the formula for the equivalent resistance for the to calculate the resistors connected in series? That is R1 plus R2. This is equal to R1 is 8, R2 is 10. This is equal to 18 ohm. We got the answer 18 ohm, the equivalent resistance. For all these, for replacing all these resistors, we can use a single resistance which is equal to 18 ohm. Okay. Now, the second question, total current flowing in the circuit. Second one, total current. Now, total current in the circuit, total current in the circuit by Ohm's law. By Ohm's law, we have V is equal to I into R. Therefore, I can write V divided by R. This is equal to, V is how much? It is 12. R is how much? It is 18. Okay. This is equal to, it is 2 9s are 18. 2 6s are 12. This is equal to, I can write 6 divided by, it is 9. Okay. Now, take one 0. 9 ones are 9. 9 6 are 54. Okay. Again you take 0. Again it will be 60. Again you will get 6. Therefore, current is 0.66 ampere. Okay. So, the current flowing through the circuit is 0.66 ampere. Hence, we have solved the problem.